The previous dance was performed by students of UPN Veteran Yogyakarta from Traditional Dance Activity Unit. It is named Golek Ayun Ayun Dance from Yogyakarta. This dance is a classical Javanese dance, comes from the court of Yogyakarta. It depicts a young woman's desire to always look for her best. Okay, before we proceed, I would like for all of the attendants to pray. To the next event, I would like to all of us to stay put and stay seated to sing the national anthem of Indonesia Raya and Mars Bela Negara song. Thank you for your time to listen to the national anthem of Indonesia and Mars Bela Negara. The next event, we are going to have a speech from the General Chair. And the first speech is coming from Purnawansyah from Muslim Indonesia University in Makassar.
Thank you, moderator. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone, and peace be upon you. All praises to be the Almighty God. We thank Him for the countless blessings which have been bestowed upon us. Ladies and gentlemen, currently we are facing COVID-19 for nearly a year, a global pandemic that has changed our way of being a working school, colleges, and universities are even closed by the government in many countries to avoid the more significant widespread of it. However, it does not mean that nothing we can do. We are encouraged to immediately prepare, respond, and recover from this situation, start our normal life, and here we are. We virtually gather in 2020 International Symposium on Advanced Intelligence Informatics. On behalf of the committee, I'm honored and pleased to welcome you all to this online symposium organized by ASCII China section and hosted by Universitas Pembangunan Nasional Veteran Yogyakarta Indonesia, Universitas Muslim Indonesia, and Universitas Ahmad Dahlan Indonesia in collaboration with the International Journal of Advances in Intelligence Informatics. Considering the success of the first and the second symposium in 2018 and 2019, today we are proudly host this international online forum to encourage students, university lecturers, and practitioners to share knowledge, talk, expertise, latest information, and developments intelligence informatics area. This symposium generally attract authors from various countries, including India, Thailand, Iraq, and Indonesia, with 25 papers accepted to be presented. Ladies and gentlemen, last but not least, please accept my deepest thanks to all participants for the contribution which are the foundation of this symposium and all of the committee members who have worked on putting this successful conference together. I hope that you will find the symposiums valuable and enjoyable. Assalamualaikum warahmatullahi wabarakatuh. Thank you very much and please be upon you.
Thank you to Mr. Purnawansyah for the speech. And the second speech will come from Rectorate of UPN Veteran Yogyakarta, Dr. Muhammad Irhas Effendi, MS.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning to all of you. Greeting to all distinguished guests, keynote speakers, and conference participants of the Third International Symposium on Advanced Intelligence Informatics Sain 2020. This seminar is also one of series of activities in order of the 62nd anniversary of UPN Veteran Yogyakarta. Ladies and gentlemen, Universitas Pembangunan Nasional Veteran Yogyakarta has been taking part in organizing Sain's first conference in 2018. Since its exception, Sain is jointly organized by Universitas Pembangunan Nasional Veteran Yogyakarta, Universitas Muslim Indonesia, Universitas Ahmad Dahlan, International Journal of Advanced and Intelligent Informatics, Association for Scientific Computing, Electronic and Engineering, Indonesia and China section, Embassy of the Republic of Indonesia, Beijing, PCIM Tiongkok, PPI Tiongkok, and is jointly organized with Universitas Negeri Malang, Universitas Mula Warman, Universitas Muslim Indonesia Setiami Jakarta, and Universitas Hasanuddin. We got the offer Sain is the occasion to personally congratulate our Department of Informatics Engineering and Association for Scientific Computing, Electronics and Engineering, Indonesia and China section for the commitment and hard work to ensure the success of Sain 2020. Ladies and gentlemen, Sain 2020 was held to provide as an event for IT academic and IT expert to disseminate their knowledge on the development of computer science education and expand the network connection on the research activities. Furthermore, we intend to make this conference as a motivation for researchers to publish their ideas about theory and application of IT for education, for society, and industry in order to support the development and quality improvement of local, regional, and global researches in line with Universitas Pembangunan Nasional Veteran Yogyakarta vision to be the pioneer of national development based on the spirit of patriotism. Finally, on behalf of the organizing committee, we wish to express our highest appreciation and sincere thanks to all of our distinguished participants who attend this event. And we wish you have valuable discussion and networking. We hope all our guests are enjoying the seminar that we had. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you for the opening speech. I am for sure you don't want to be kept waiting. With this, I officially open the third seminar symposium on advanced intelligent informatics. To the next session, I would like to introduce the main event. It is a speech, one of the main event. It is a speech by Awang Hendrianto Pratomo PhD from UPN Veteran Yogyakarta and Roman Voliansky PhD from Dniprovsky State Technical University. With this, I would like Leonel Hernandez PhD to take charge as a moderator.
Good morning to all. My name is Leonel Hernandez. I am a system engineer, master in strategic management in telecommunications. I recently obtained a PhD degree in projects. I work in the Institución Universitaria ITSA in Barranquilla, Colombia. It is an honor for me to participate as moderator of this important event, Sain 2020, which is taking place virtually in Yogyakarta. Our first presenter is Dr. Awang Hendrianto Pratomo. Dr. Hendrianto, head Department of Informatics Engineering, Faculty of Industrial Engineering, Universitas Pembangunan Nasional Veteran Yogyakarta, Indonesia. Also, as lecturer in Magister of Industrial Engineering and Magister of Disaster Management. Graduate Bachelor Program at Department Informatics Engineering, Indonesian Islamic University, and Master Program at Information Technology, MT, Department of Electrical Engineering, Gadjah Mada University. Received a PhD in System Science and Management, Faculty of Information Science and Technology from University Kebangsaan, Malaysia. Our research interests are Internet of Things, cloud computing, robotics, artificial intelligence systems, and software engineering. He is a Cisco certified instructor. He has written a lot of papers, articles, and tutorials that have been published in many proceedings, conferences, scientific journals, and newspapers. in national and international level. Current research on development Internet of Things for landslide monitoring, ship navigation system, smart farming, autonomous mobile robots, vision systems, big data, analytics, image processing, and cloud computing. Current address is the Department of Informatics Engineering, Faculty of Industrial Engineering, Universitas Bangungan, National Veteran Yogyakarta. Okay? So welcome, Dr. Agwan, and you can start when you want, if you are ready.
Thank you. Good evening, Mr. Dr. Leona Hernandez. Thank you. Next, I would like present about our keynote speech. Yes, yes. Yes. Thank you. I would like present our keynote speech in the topic is palm tree calculation using HSV segmentation and blob detection. This paper created by my Awang Hendrianto Pratomo, Babang Juwono, Kartika Harisma Putri, and Silvert Priyantahalia. Our background from the research is Indonesia is the one of the country that has potential palm oil plantation. The palm oil plantation in Indonesia are concentrated in the island of Sumatra, Kalimantan, with the area of about 3.2 million hectare and had an average growth around 11.71% per year since 2030. Palm oil condition in one of the main export commodities in the oil and gas field has the impact of expansion of palm oil land in various regions, especially North Sumatra, Riau, Sumatra, West Kalimantan, Jambi, and Aceh. The expansion of palm oil plantation has several problems. One of the which is the distribution of the number of the palm tree in the plantation area. The calculation of palm tree number in the region so far has begun to change manually using satellite imagery, augmented area vehicle, by using LiDAR with image processing and another method. Digital image processing has done a lot of applied in various fields such as material damage inspection, plastic marine debris, health studies, and agriculture. In the field of forestry and agriculture itself, had a lot of digital image processing to detect disease crop using satellite mapping, with the highest accuracy around 98%, and the forest detection with it up 97.6%. And the use combination of several methods, such as general advanced network, conventional neural network, and support vector machine. Digital image processing is also wide in using detecting, calculating of number of trees, as well as to measure tree size, tree height to measure using regular camera. Photo imagery is able to provide 4% error rate better than some previous studies. Our research is begin about the moving object. The camera is placed in the drone, and then the the drone is mapping from the palm tree area. They're calculating like moving object. So after the drone is moved to the ground control or base station, he have the actual calculation of the tree. So based on this research, I will start from the calculation using the moving object. This is the main of the digital image processing to calculate the inspection like plastic, car detection, and another process. The application of digital image processing in the tree detection was also successfully carried out the result imagery from the camera with high definition resolution for 5 different type of bamboo tree. The set of carry out the study are pre-processing, sobel edge detection, sclerotation, feature extraction, classification, and recognition. Research related to identification and calculation the number of tree carried out using several technology like using a LIDAR, also airborne laser scanning, and satellite imagery. When meanwhile, identification and calculation of palm tree is carried out by utilizing drone and computer vision imagery. In the calculation of palm tree carried out using Haar cascade classifier, only identify 89%. Based on this research of the previous study, we conducted research by using HSP segmentation and black blob detection to identify and calculate the number of palm presentation from the moving object. The method from our research actually starting for the image segmentation, the image segmentation process to extract meaningful image characteristic from the source and to be analyzed. The input data are video frame to convert to segmentation frame. To the process are HSV setting to RGB to HSV conversion and noise filtering. And then the process of HSV is basically start from input data, the input data from the camera from drone, and then the next processing HSV setting for remove the background, and then image compression for to HSV, and then noise filtering to remove the noisy from the image, and then the last result is segmentation. And then from the object detection, this is the basic algorithm, basic formula for compression from HSV to RGB, from RGB to HSV. The RGB file compression R value that green and blue, and then RGB value comparison with green value larger than R and B value. And then the third is RGB value comparison with the B value larger than R and G value. And then the result is from the 60 degrees from the value from hue. And then the next step is object detection. Object detection is process to detect the certain object from the image to improve the detection accuracy. From the input from object detection, starting from the image segmentation process. After the segmentation process, we have the object from the rectangle mark base, contour, and blob detection. From the blob detection to detect the spatial region of feature from the image. Detection blob from the input is calculate the mean of the size of the object. The size of the object is to know the how the big how the size the palm tree. And then after this is the algorithm for the blob detection. The input is from the segmentation object. Output is embedded information in the frame. And the next step is object tracking. This object tracking is that we use in our research from the tracking that object are calculated before, and then we use tracking a method to extract the position and size the object in the frame. So when the drone is moving from one area to another area, he had information about the counting of the palm tree. In this research, we use model to detect the tracking of the object using the 5 conditions. The first condition is only position before tracking, and then condition true two position before tracking. Condition 3 are the 3 position before tracking, and condition 4 are 4 position before tracking. The 5 step is there are 5 more position before tracking. And then based on the position, we know the 3 are already calculated or not calculated before. After the object tracking, the next process is object tracking flow. The object calculation state is the application state counting object using video data. Input in the calculation process in the form of blob object that we have tracked and generated output data in the form information about how many objects are calculated. The process calculating object, checking whatever to detect the object has fulfilled minimum size or not. If the object has fulfilled condition, there is the considered to actually an object are entered into the system calculation. That the process is from the camera object distance calculation, and then if the object distance calculation is less than the tracking distance, so this has a block detection. If the block detection, that the next process is object tracking. After the object tracking, object calculation, and then we had the calculated how many palm tree in that area. This is the object calculation state from the digital image. Is the size the bigger than minimum size block on the object, and the result is the how many tree and that detected in our research. That our research have a result. The segmentation carried out by observing calculation how much percentage of the system created can distinguish palm tree object from the background. The image segmentation testing result is average accuracy 96.32% with the highest accuracy of 100% and the lowest data accuracy is around 89.42%. The process testing of object detection state carried out by observing and calculating how much percent of the system create and can recognize the palm tree as an object. The object detection test yield average accuracy of 96.76% with a blob size of 10. The lowest test on object detection was 50.81% with the blob size is 50. The process of testing and tracking the state of object in carry out the observing and the calculating the percentage of the system created can track detect object until it's count in the system. The process testing the calculation state of the object carried out by looking at the final result of the system calculation, then compared to to manual calculation tracking to test the result, average accuracy is around 90.60% with the blob size as 10. The lowest test object detection is 32.98% with the blob size is 50. Besides, another the problem for our research is the cloud shadow. The cloud shadow is more it make the image is not clean out because the intensity of the lighting is lower. This is the problem for our research to detect in the area that have a cloud shadow in this area. Besides accuracy, the testing, running time also tests. The average time each process is around 90.2 milliseconds, and the process time test longest than that 77.3 milliseconds for image segmentation stage. Our conclusion is the problem of calculation palm tree object can be solved using HSP segmentation for moving object using a method and blob detection with average accuracy is 90.60%. The best accuracy for imagery with the height of range 7.3 meter until 47.4 meter in the generated from the probe size of 10. The result also has the best accuracy for detection, tracking, and calculation if the lowest height is 70.9 meters with 100% accuracy, while the best segmentation accuracy is 2.3 meter. The highest accuracy is 97.20 seconds. This is our presentation. Thank you. I will to give back to the moderator, Dr. Leonel. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Many thanks to Dr. Aguan for his excellent presentation. His research is very interesting. Thank you. Thank you, Dr. Aguan.
Thank you. Welcome.
Okay. Now we will have our second presenter, Dr. Roman Doliansky. He is currently Associate Professor of Electrical Engineering Department at the Dnipropetrovsk State Technical University. He earned his engineer degree in electric drives from Dnipropetrovsk State Technical University in Ukraine in 1999. His master's degree in electric drives in 2000 from the same university, and his PhD in electrical engineering from the National Mining University, Dnipropetrovsk, Ukraine, in 2005. In his PhD thesis work, he solved the control optimization problem for an electric drive with black slash in gear. Now, his research interests span various areas of optimization and control, electromechanical and electrotechnical systems with regular and chaotic dynamics. The most recent achievement is the use of interval math for designing mathematical backgrounds to solve optimization problems for linear and nonlinear dynamical systems from a single viewpoint. He's serving as an editorial member in 3 international journals, as well as has served as reviewer and TPC member on several IEEE conferences. Boliansky has over 30 referred publications in international journals and conference proceedings, and more than 50 in all Ukrainian ones. Today, he's going to present us his work titled Discrete Time Control Strategies for the Chuas Circuit. At the end of the Dr. Roman's presentation, we will be presenting the question of the attendees. Dr. Roman, you can start from this moment, if you are ready.
Yes, thank you. Can you hear me?
Yes.
Yeah.
Very clear.
So I share my, just a moment. I am share my screen. Dear colleagues, let me introduce myself. My name is Roman Volyansky, and I represent the Electrical Engineering Department at Dnipropetrovsk State Technical University. I would like to thank the organizer of this conference who invited me to make my speech today. It's a very big honor for me to represent our scientific achievement here. The topic of my speech is discrete time control strategies for the Chua circuit. Just a moment. From its beginning, the electrical engineering operates 3 main passive elements, namely resistor, capacitor, and inductor. Their properties and features are well known and widely used in various circuits. Also, it have a known mathematical description of these elements, and as well as some laws which describe interrelation between process in these elements. Thus, it's a well-known fact that, for example, capacitor charge depends on voltage on it, and current through resistor is proportional for to voltage on it, and so on. We can we can meant different interrelation between this element. But in the last time, it was discovered a fourth base element of electrical engineering, namely memristor. This element define interrelation between magnetic flux and between charge. This element was proposed by Leon Chua in 1971, and this element complete the theoretical quartile of fundamental electrical components. It's known several implementation of this element. One of them you can see on this slide. Here you can see so-called titanium dioxide memristor. It consists of four different layers, and it's designed with nanoscale technology by Hewlett-Packard in early 90, I'm sorry, in early 2000. It operates with high frequency signals and has a nanoscale teeny size. Also, it is known an organic polymer memristor, different multi-layer memristor, so-called atom risto, ferroelectric memristor, and many others. Due to its construction, memristor has several unique properties. One of them is the nonlinear negative resistor resistance. You can see so-called voltage ampere characteristic on this slide. This characteristic and other memristor features make it operate in different application. The main of them can improve different electronic devices dramatically. For example, it is possible to organize nanoscale low power memory, and it's possible to design a different neural network, and it also can be used in various filter and signal processing application. Unique properties of memristor produce a lot of various periodic scientific publication. For example, on this slide, you can see screenshot from Scopus database, which shows that more than 7,000 publication about memristor are known for this day. And also more than 200 records can be found in IEEE Explorer library. One of memristor application is chaotic dynamic generating. This device generates chaotic oscillation, and it is known as Chua circuit. This circuit was suggested by Leon Chua, and it designed with four electrical components, namely resistor, inductor, capacitor, and fourth element, which I was meant about, this is a memristor. As about this circuit, we can find in, for example, Google Scholar, what more than 20, more than 90,000 records present in this database. In Scopus and IEEE, in a Scopus Web of Science and IEEE Explorer library, we can find less publication, but we have significant theoretical and practical results. In their publication, after authors who study Chua circuit solve different problem. The main of this problem are shown on this slide, and the solution has a big theoretical and practical meanings. Because it is possible to use well-studied circuit, well-studied electrical circuit with and which designed with single chip technology, which is very known, very well known circuit, and which can produce a signal which we want this circuit have. In our study, we try to solve this last two problem, and to solve this problem, we consider a controlled Chua circuit. Contrary to classical one, this circuit have a controlled voltage source, and this source allows us to control circuits in each branch of this circuit, in each branch of this scheme, and we can control voltages on every element with circuit as well. To model this circuit, we use well-known Kirchhoff rules. We use so-called first Kirchhoff rules, which define interrelation between current in this circuit. And we use second Kirchhoff rules, which define the voltages on element, voltages between element of this circuit. And we consider the inductor of this circuit as inductor with ferromagnetic core, and we use following approximation. This is a very good approximation for magnetic curve because of there are no any analytically description for magnetic curves, and we must use only some approximation dependencies. If we solve this equation, we can obtain a model for Chua circuit in operator form. Here, S is the Laplace operator, or operator which show derivative. And we use a classical nonlinearity of memristor, which was given by Chua. This equation these equations have a different physical nature. For example, this equation solved for voltages, and this one solved for current. And this is a some drawback of this model. To make this drawback no significant, we transform above mentioned model into a dimensionless form by giving into account some state variable. With this state variable, we can get a dimensionless Chua circuit model, and you can see this model on this slide. We can see some block diagram for developed model on this slide. This is a continuous time block diagram since it used continuous time integrator. And it's very hard to use this block diagram. It's very hard to use this model to implement it on various discrete time devices, for example, controllers or computers. That's why we transform it into discrete time domain. We use a well-known approximation for derivative operator. We use a well-known finite difference approximation, and then we can get the following discrete time equations. This equation this equation solved for some free state variable in a state domain. This is not quite convenient to use free equation, and that's why we transform this equation into single equation which use not only elementary mathematical function like this equation, but which use shift operator, which is shown here as operator Z. And on this slide, you can see a block diagram for such a model. Now we design a control system. We control voltage source above shown system by using a symmetry principle. According to this principle, we can find a control law by inversing mathematical description of object. So in that way, we can define a controller for Chua circuit like it shown here. It contains three expression. It contains three equation. The first one describes the difference between desired and controlled state variable. Second one define some nonlinear function which compensate nonlinearities of Chua circuit. And second one, and third one describe voltage which should be produced by voltage source to control the Chua circuit and to get it moving in desired trajectories in desired paths. You can see simulation results for using Chua circuit with proposed algorithm here on this slide. And you can see a conclusion for my work here. The main of them is a possibility to use a symmetry principle to design discrete time controllers. I would like to say that this possibility has a strong theoretical background and it can be used not only for control the Chua circuit, but for control any dynamical object, any object with regular and chaotic dynamic. Thank you for your attention.
Many thanks to Dr. Roman for his excellent presentation. His research is interesting, very interesting. We will check if there are questions from the attendees in the chat. Well, right now, no, but I have a question.
I have
a
question.
question. Yes, and just one. You mentioned that the Chua circuits can serve as a chaotic oscillator
Yes.
to produce two random signal sequences that are used in crypto communications and robotics.
Yes.
Can it also be used to improve wireless or network communications?
Yes, it used as a coding generator for secured data transmission, and our colleagues from our university study this problem, and they are had some results in this field.
Okay, very, very good. Very nice. Thank you, doctor. Let's see if there are another, there is another question. No, I don't, I don't see.
May I ask to the presenter?
Of course, please.
Okay, thank you. My name is Adi. I'm from UPN. I just want to know about some elements. You mentioned that you use titanium oxide and platinum, right? And I just want to know how size the elements and what methods you use to combine TiO and some and platinum in your construction your device. Maybe the second slide of your presentation. A picture of elements, component elements. Yes, that's right.
You mean
Yes.
this slide? No, unfortunately, we don't produce this element. We use it as given. So I cannot say anything about combining these elements.
Oh.
It was made by Hewlett Packard, and unfortunately, I don't know how they do it.
Oh, you didn't make it.
Unfortunately.
Okay, thank you.
Another question? Mr. Raji, do you have a question? No? Okay. Another question for Dr. Roman or Dr. Awan for the first presentation?
Yeah. Donald, hi. How are you?
Yes. Hi, how are you?
I'm good. Yeah. I have a question for Dr. Foliansky. It is a general question, but I think your research is very interesting. Yeah. I just wondering how if we for example, if we want to do the same research, collaboration research with you with the same topic, what do we have to prepare in Indonesia to start the research like yours? Yeah. What is the first step? What is the first step? This is my question. This is very basic question, but yeah. What is the first step to do your research?
I'm sorry, what can you repeat your question?
Yeah, I think your research is very interesting. Yeah,
Yeah.
but we are from. Let me introduce myself first. My name is Aji. I'm from University of Malang. Yeah, University of Malang. Um, uh, Actually, I want to do the similar research for like yours. Yeah, I have several laboratory for power system, communication network, and etc. Yeah. So if I want to, if you are willing to do a collaboration with research with us, what do we have to prepare? What is the first step? What is the first step? For example, what kind of basic research we have to prepare? The basic one, because I just actually this is not your research is not my field, but it is very interesting. I want to grab it and ask my colleagues in my hometown to do the similar research. In what I mean is, for example, by your supervision, for example. Yeah. So what do we have to prepare?
Okay, can you share some your contact? We send you information what we do, what we can do, and maybe you share same information with us.
Okay, yeah. Okay, I will share you the email. My
Yes,
email, right?
yes,
Okay,
yes, yes,
yeah.
yes.
So we can after this we can have a share everything. Sorry. Yeah. Okay. Yeah. Wait a second. Chat. Comment. I think that is only my question. So I will contact you later for
Yeah. Okay.
yeah
Okay.
yeah for next discussion. Okay.
Okay. Thank you for
Okay.
contact.
Yeah. Yeah.
Hey,
I already send you my email
Yes, yes, yes.
and also
I
my
see.
phone number.
Yeah, I heard it.
Okay. Thank you for the time.
Thank you too.
thanks, Ayi. What another question for Dr. Roman?
You're welcome, Lionel.
Okay. Another question for Dr. Roman or Dr. Awan? I have one for Dr. Awan. It's very interesting, your research. I just was wondering, in which other sector or industry can a study similar to HSV segmentation and blood detection be applied?
The loop segmentation actually using for the calculation, like in the toll and the highway. It, from the basically starting the research from the calculation of the counting and classification of the car from the highway, and then I will improve for the detect for the palm tree, because actually it's the same problem that the different model is the if using the drone, the object has moving, not the object. I using from the UAV and then calculated from the tree. Another method that we use from the calculation of the car, the still camera and the object car is moving for the calculation and classification of the object.
Okay. Thank you,
Thank you.
doctor.
Thank you.
Okay, another question. For our presenters. Are you going to ask something, Aji? No.
Dr. Awang, yes, I have a question.
Okay. Hello, Mr. Aji. How are you?
When you invite us to the Migodok again. No,
Actually,
just
if
kidding.
in Yogyakarta we can noodle, we can noodle together.
So,
This
no,
Dr. Leonel and maybe from Dr. Roland Polanski.
oh yeah. Uh, now this is my real question. I have I just I just thinking about the ethic of flying a drone. Yeah, if you fly the drone and take a picture of something, which is it is a private object of something, do you have a any consideration about the ethic of doing of taking picture of others?
Yeah, actually, if you drone using drone is follow the ethic. Yeah, we cannot take a picture from the private area, and then actually in Yogyakarta also we have a regulation, the time and the highest drone for taking picture or the flying object. Actually, to save the first is about the flight, and then the another is about the regulation for the ethic to take picture in the private area. So actually
Okay.
we must follow the regulation about it.
So there is a regulation about flying a drone.
Yeah,
Yeah.
I have
Okay.
actually regulation. Indonesia have also have regulation about it.
If someone break the law, what is the consequence?
Actually, if for the highest regulation, actually from the flight apa, uh, airnav that to take over from the flight, we can to take over the control the flight to go to the ground station or to take over to fly to another place. Actually, from the regulation of the airnav must follow, because it make it dangerous for the flight navigation. Actually,
Okay.
the regulation of the highest moving object, like that. If the regulation of
Yeah.
the private area, actually we must follow the regulation. If you share to another, like the YouTube or Facebook, the secret area, we can we can use regulation of ITA from the Indonesia, like that.
Okay. Okay. Thanks, Doctor.
Welcome, Dr. Aji.
Okay.
Okay. Another question? Any other question for our lecturers? Dr. Wang, is there another PAM pre-calculation, a different method, different for HSB, the segmentation or block detection? Did you compare a different method or only these ones?
Actually, the another segmentation we has used the CBR, UCBR, and another method like actually from the blob basically from the segmentation is just we try to compare with UCBR, UCBR like yeah UCBR chrominum and chrominum from the detect the to remove the background on and foreground like that.
Okay. Thanks, doctor. Okay, another question. Well, with this last question, the space for the main conferences of the event is concluded. From this moment on, there will be a break for lunch time, and we'll continue with the presentations organized according to the event program in the virtual rooms designated for it. Thank you very much for your attendance and participation. Cordial greetings. Well, many successes to the speakers and that the attendees were totally satisfied with the conference. Thank you very much.
Thank you.
Terima kasih for all.
Thank you.
Best regards. Thank you, doctors.
Thank you. Welcome.
Thank you for your attention. First of all, I would like to repeat our next session is lunch breaks, presentation sessions with 4 rooms, and the 2 rooms for machine learning and soft computing track. The second room will be, the third room will be computer vision and pattern recognition room. And the third room, the fourth room is data mining and big data analytics. And after this, we're going for a lunch break. Thank you for your participation. I'm sorry for the inconvenience. I would like to repeat for the new information. Our next sessions will be lunch break in 30 minutes. And the next session after the lunch break is a presentation sessions with 4 rooms. The first rooms and the second rooms are for machine learning and self-computing track. And the third room are computer vision and pattern recognition room. And the last room is data mining and big data analytics. Thank you for your participation.